Hello, so my name is Tapio Pitkäranto, and the topic of this video is actually what is transformer learning. And I feel that the greatest innovation that humans have made during the last 10 years is a mathematical innovation called the transformer. Especially that is true for the artificial intelligence field, where the transformer enabled the current large language models and generative AI boom. And I would say that even transformer redefined what artificial intelligence today means. I have seen many long videos explaining how transformer mathematics is working, but I haven't seen a simple one that would explain that what is transfer actually learning. So that's in the core of this video. But let's start with a very simple example. So what happens in your head when you see this sentence? So an overweight gray cat is in front of the sofa and might be about to jump onto a table. Now, your brain transforms that into something like this. So some kind of picture appears in your head. And in your head, there's a few segments in your brain that are part of this language processing. But please be mindful that language is primarily a communication tool. Language it's not necessary for thinking. And before we go to any analogs, what limitations human brains might have, when transformer sees the same sentence, it simply uses mathematics. And the main core in the transformer is what's called the attention function with multiple heads. And the mathematical notion is a bit hairy, but essentially it's a dot product in vector space together with some nonlinear functions. And what you should know about the mathematics, everybody should know this, that transformer actually transforms the words, and it does not represent the words as they are after the first step. And it can use other input. It doesn't have to be words. So you can use image generation or video generation or other inputs. But anything that you put into the transformer, it is being transformed, as the name says. And this mathematics doesn't have the same limitations as human brains. So if humans have certain limitation, then you should just check this mathematics and try to understand what limitations this learning might have. And in this mathematics, there's a number of attention heads. We will use 100 as an example. And then there's layers. So consecutive attention heads plus other neural networks. We use 100 as an example here as well. But then into the core, so what is transformer actually doing? After it has been trained and after it sees this sentence, transformer has learned, first of all, how to represent that cat in a vector space. It has learned that. It's not hard-coded by any means. It has learned about 100 ways for that cat to relate to other words and any other word as well. But let's use this cat as an example. It has learned how to fuse the meanings of words in the same context using about 100 abstraction levels. And for each word, let's say cat, it has actually learned 3 projections for this attention. So we get about 30,000 ways for one cat word, how those can be connected with other words in the context and fused throughout those layers. So if we assume that there would be 50,000 words or tokens, the transformer has learned about 1.5 billion ways how these associations and fusions can be made. 1.5 billion ways. That's what the mathematics is doing. Then there is another neural network in the transformer architecture, which is sort of old-fashioned neural network, and it's not in the core of this presentation. But I'm just commenting that also that is learning. But what we touched upon was this attention function in the left-hand side, and then there's the traditional neural network that combines things, for example, a heavy gray animal positioned in front of the furniture, etc. But that's not in the core of this presentation, so I will thank you for listening, and if you have any questions, feel free to share your thoughts with me. Thanks for listening.